So the first thing you want to do when you hit an example that looks like this is just take a deep breath and realize that it's probably not as bad as it looks. It's probably less scary than it actually is. Uh, the first thing I notice when I see this problem is I've got this inequality going on up top here. And a lot of times, when I see that inequality, it really kind of harkens back to a squeeze theorem. Right. The squeeze theorem is all about sandwiching two equations around a middle equation. And really the only time you see inequalities when you start talking about limits is when they want you to apply the squeeze theorem. The other thing is, they start asking you these questions in a very roundabout sort of language. What, if anything, does this tell you about it? That again, when they just want you to do a limit using one of our first standardized limit options, they're just going to ask you to find a limit. This extra language, again, like bells and whistles got to be going on that something else is up. And again, that combined with the inequalities above tell me that I'm probably looking at a squeeze theorem. I tell you the same thing I tell everybody, which is no matter what, I'm always going to try option one on any limit problem. You again would be surprised how often option one works. Option one for me means just plugging in that x value, whatever they're giving us for the x value down below there. I'm going to go ahead and just plug that in everywhere I see an x in the equation and see what happens. On the top, I get 0 times the sine of 0 over 2 minus 2 times the cosine of 0. And so what you get on top is 0 times anything gets you 0. And on the bottom, you get 2 minus, and then the cosine of 0 is 1. So you get 2 minus 2, so you end up with 0 over 0. So that option 1 is going to fail us. And so what you got to do is go and see if the squeeze theorem will work. The first thing for the squeeze theorem is they always want you to have that setup where you've got for sure these equations. They normally say something like g of x is less than or equal to h of x is less than or equal to f of x. That you've got some scenario where this equation that you actually care about is in the middle of two other equations. So here we can see the equation that we actually care about is conveniently, we're told, in between two other equations. And so what we know is if we can find out that the limit of this equation is equal to the limit of that other equation, f of x, well, there's only one place that h of x's limit could be, and that's in between those two things, which is the same value, right? If this answer is 3 and this answer is 3, well, the only thing that can be in between 3 or equal to 3 is 3. And so what you'll do is you'll find usually that the limits on the left and the right are easy to do, and there's something that you can find the value of. So I'm going to start and I'm going to say the limit as x approaches 0 of our equation on the left, which is 1 minus x squared over 6. And then on the right-hand side, I'm going to do that very simple equation, the limit as x approaches 0 of a constant of 1. So looking at the first one, back to option 1, plug that value in. So we plug in 0 for x, and we get out of here 1 minus 0 squared over 6, which equals 1. Then on that right equation, well, that's even easier. The limit of a constant is itself, so this limit value is also equal to 1. Since the value above, the limit value above is equal to the limit value below, what we know is that our actual limit that we care about has to live in between them. So we know that this has to live in between. The limit as x approaches 0 of x times the sine of x, all of that over 2 minus 2 cosine of x, and all of that needs to be less than this 1 on the right side. Well, what does that mean? If these two values on the outside are the exact same, that tells us that the value of the limit in the middle of them has to be the same, because if it's in the middle, there's only one place for it to be. The middle of 1 and 1 is got to be 1. So you know that your limit of this equation that you couldn't handle is equal to the same value. It's also equal to 1. So again, squeeze theorem, you can kind of tell, usually you've got some inequality given to you. Then you're asked to find the limit of one piece of that, the middle piece always, right? And then from there, we go through our process of finding the limit on the left, finding the limit on the right, and showing that those two things just so happen to be equal, which means the only place that the limit you actually cared about could be is at that exact same value. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.